Welcome to Daily Papers.
Today, we're looking at a fascinating question. How well do artificial intelligences actually work together? We hear all the time about how smart AI is, but if you put a bunch of them on a team, can they collaborate as well as a team of humans?
It's a great question, and a new paper puts it to the test. Researchers from Indiana University created a simple coordination game and had groups of humans play it, and then had groups of AIs play it. The results reveal some really deep differences in how we cooperate versus how they do.
So let's break down this game. It's called group binary search, which sounds complicated, but the idea is actually very simple.
Imagine you're in a group with, say, two other people. You can't talk to each other at all. There's a secret target number that you're all trying to find. Let's say it's 80. In each round, every one of you secretly writes down a number.
So you might guess 20, another person guesses 30, and the third person guesses 25. The game master then adds up all your guesses. In this case, that's 75. They then announce to the whole group, your total sum is too low.
And that's it. That's the only clue you get. You don't know what anyone else guessed or who guessed what. You just know that as a group, you undershot the target. So for the next round, everyone has to adjust their number.
It's a real challenge of coordination. You probably need to increase your number, but by how much? And what if everyone else increases their number by a lot too? You could easily overshoot the target and be told too high in the next round. The goal is to get your group sum to land exactly on that secret number in as few rounds as possible.
So the researchers had groups of humans play this game, and then they had groups of several different large language models, the AIs that power things like ChatGPT, play the exact same game. So who was better at coordinating?
Well, in a nutshell, the humans were. In almost every setup, the human teams were able to solve the puzzle and find the secret number in fewer rounds than the AI teams.
And one of the biggest reasons why came down to the kind of feedback they got. In some games, the players only got simple directions, like too low or too high. But in other games, they got more detailed numerical feedback, like you are too high by 20.
For the human teams, that extra information was a game changer. They used it brilliantly to fine-tune their guesses and solve the puzzle much, much faster.
But for the AIs, that numerical feedback barely helped them at all. They really struggled to use that more precise information to coordinate better. It's like giving one team a detailed map and the other team a blurry photo, but they both arrive at the destination at the same time. The team with the map clearly isn't using it very well.
So the researchers wanted to know why the AIs were struggling so much. They identified two key behaviors that really separated them from the humans. The first is what they called high volatility, which is basically a tendency to overreact.
Right. Let's say the group was told their sum was too low by 10. A team of AIs would often overcompensate wildly. They'd all increase their numbers so much that in the next round, their sum would be too high by 15. They just kept swinging back and forth, overshooting the target again and again.
Humans did the opposite. We tend to underreact. If we were too low by 10, we'd make smaller, more cautious adjustments, maybe only correcting by a total of 7 or 8. It's a bit slower, but it's much more stable. It's like trying to steer a giant ship. You make small, careful turns. You don't just yank the wheel from side to side.
The other strange behavior the AIs had was something called action bias.
Yes, this is fascinating. The AIs felt like they had to change their number every single round. No matter what, they always submitted a different guess than the round before, maybe because they associate taking an action with making progress.
But that's not what the humans did. In the human groups, especially as more players were added, some people would just decide to stick with their number. They'd implicitly think, you know what, my guess seems fine. I'm going to hold steady and let other people do the adjusting.
It's a brilliant emergent strategy. Without ever talking, the group spontaneously creates different roles. Some people become stabilizers who anchor the group, and others become adjusters who fine-tune the sum. This makes the chaos much more manageable.
The AIs never did this. Every single AI agent changed its guess every single round, which just kept adding noise and volatility to the system.
And perhaps the most crucial difference of all was learning over time. The experiment wasn't just one game. Each group played a series of 10 games.
The human teams consistently got better. They learned from experience. The average number of rounds it took them to find the number went down over the course of the 10 games. They were learning the dynamics of their group.
The AI teams showed no improvement at all. Their performance was completely flat. They approached game number 10 with the same clumsy strategy they used in game number 1, even though the full history of their previous games was available in their memory.
So, what's the big takeaway here? This study shows there's a huge difference between the ability to process information and the ability to use it to coordinate and adapt within a group.
Exactly. Humans rely on these subtle, unspoken strategies to work together, being cautious, taking on different roles, and learning from shared experience. The AIs, for all their processing power, seem to be missing this crucial layer of collective intelligence.
It's a good reminder that just putting a bunch of individually smart agents into a team doesn't automatically make them a smart team. You can end up with a group of hyperactive individuals all trying to steer the ship at once.
Whereas the humans, even without communicating, acted more like a choir, slowly and carefully tuning their individual notes until they created a perfect harmony.